GTA Math, what's up? So today I don't know what to call this problem, but this is what it was called in my homework. It was just like determine, and then it had this integral, and then this other thing that's an integral that's weirdly written. But never mind that, we're gonna solve this. So when you see a problem like this, actually, the first thing you have to do is u sub this inside value. So we're gonna say u equals 7x plus 2 dx. This is one of those problems where like I have to just do it and then kind of explain towards the end, because even in my understanding currently, this problem is very different, right? So we u sub, we're going to take the derivative. We're going to be left with 7 dx. We're going to get the constant. And now we're left with 1 over 7 du equals dx. So here's the part that gets interesting. We need to figure out what happens when we input these values, 3 and 0, into our u sub. Actually, I'm doing too much. So we're going to end up with this. When x equals 3, we're going to have 7 times 3 plus 2, and this is going to equal 21 plus 2, which becomes 23. And then when we have x equals 0, we're going to use the same method. So this zeroes out, and we're left with 2. That's a cool 2. So what's interesting now is we've actually found our boundaries for this other part of the integral here. And now that we have our upper, that's a p, I promise, and our lower bound, what we can do is we can substitute the du value we have into this integral that equals 10. So here's what that looks like. What we have is this. We have the integral 23 to 2, and we're going to take this 1 over 7, and then we're going to put inside of here f of u du. And then since we already know that our f of u du, we evaluated the boundaries for, we can substitute this value in, because when we integrated, not integrated, but when we substituted the u function and took the derivative and we took the constant out, we now know that these two integrals are actually similar. So the value 10 that we have up here is actually really just this 1 over 7 times the remainder of what's left from this integral when it's evaluated, which is 10. So our final answer is going to be 10 over 7. So I never got an explanation in class, but to my understanding, once we took the derivative of the f of x function, we found out what the constant was when this was the boundary. But once we figured out that this boundary is the same as this other boundary once it's evaluated from the original f of x, we're left with 10. So if we evaluated this integral, the actual f of x value of it is 10. And since we're taking the du, which is here, and we're inputting it as a constant and multiplying it by the final answer of the new integral we found out with these limits, we created the upper and lower bound, we're left with 10, and then we multiply these two things together. This gives us our final answer. I know it's complicated. It really still doesn't make sense to me, but I felt like it was worth sharing it. So if I forget how to do something like this, at least I can reference it. So yeah, there we go. GTA, thanks for sticking with me. I appreciate everybody. Let's continue to learn, love, grow together. Take care.